Welcome learners. Our today's lesson is Organic Chemistry 2. We're going to look at alkanols. That is, we're going to look at nomenclature, isomerism, and preparation. So the first one look at this general formula of alkanols is given by CnH2n plus 1 OH. Now, where N is the number of carbon atoms and OH is the hydroxyl group, which is a functional group. Now, next is nomenclature of alkanols. Alkanols are named by joining a prefix indicating the number of carbon atoms to a suffix anol. Now, the prefixes include, when it is one carbon atom, the prefix meth, 2 eth, 3 prop, 4 but, 5 pent, 6 x, 7 ept, 8 oct, 9 non, 10 is dec. For example, you are told that when n is equal to 5, this prefix is pent. Is joined to a suffix anol, you get what they call pentanol. The molecular formula of pentanol is C5, 2 times 5 is 10 plus 1, 11, H11, then you have OH. Now the open structural formula for pentanol becomes, you draw 5 carbon atoms, 1, 2, 3, 4, 5. Then you place single bonds in each of the carbon atom. Each carbon must have 4 bonds. Then you place the hydroxyl group on one end. Then the rest becomes hydrogen atoms. Hydrogen atoms. So that's called open structural formula. The condensed formula from this one, you take the first carbon hydrogen, take the first carbon, it has got 3 hydrogen atoms, so it becomes CH3. The next is, this one is CH2, 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 CH2. So I place here CH2, because we have 4 of them being similar, I place the brackets, then 4, then OH. That is called condensed structural formula. Now note that for alkanols with more than 3 carbon atoms, the position of the hydroxyl group must be shown in the name. That is, when the name is in a structural formula. For example, you are told, you're given this structural formula. Then you're told to name this one here. I say the hydroxyl group must be shown in the name. So I start numbering from this side. I say 1, 2, 3. So the name of this compound here becomes propan (1) -ol. That is, you have to show position of the OH in the name. Now, the next thing we look at is classification of alkanols. Alkanols are classified as primary alkanols, secondary alkanols, and then tertiary alkanols. Primary alkanols is one in which the carbon atom attached to hydroxyl group is joined to 2 hydrogen atoms, as shown. I have a carbon atom here attached to an OH is joined to 2 hydrogen atoms. So in this end means I have a carbon atom. So this carbon attached to OH is joined to two hydrogen atoms. That is called a primary alkanol. Next is called secondary alkanol. This one is one in which the carbon atom attached to the OH is joined to only one hydrogen atom. As shown, I draw the carbon atom attached to OH, then this one is joined to only one hydrogen, so it means the rest will be carbon atoms. CH3 here, and then this side is CH3. Then the last one is tertiary alkanol. A tertiary alkanol is one in which the carbon atom attached to the hydroxyl group is joined to no hydrogen atom. Example, you take a carbon atom attached to an OH, then there are no hydrogen on this side here. So one I have here is a carbon atom. I have a carbon atom here, and then I have a carbon this side here. So that's called a tertiary alkanol. A tertiary alkanol. Now the next thing we look at is naming of branch alkanols. Now a branch alkanol is obtained when substituent groups is attached along the longest continuous carbon chain. The substituent groups includes alkyl group, e.g. methyl with a formula of CH3, ethyl with a formula of C2H5, and then we have what they call halogen group, which includes chlorine atom named as chloro, bromine atom named as bromo, iodine atom named as iodo, and then fluorine atom named as fluoro. Now the rules of naming a branch alkanol: one is identify the longest continuous carbon chain containing the hydroxyl group. Number two, number the carbon atom from the end near the hydroxyl group. Number three, locate position of the branches. In that one, you're supposed to note that between a name and a numeral, you separate by hyphen. Between numerals, you separate by comma. For more than one similar branch, use di for 2, tri for 3, tetra for 4. For more than one different branch, name them alphabetically. Then lastly, do not use capital letters between names. The systematic name of the compound below. So I said the first thing you're supposed to know is you're told to identify the longest continuous carbon chain which contains the hydroxyl group. This is why I have the hydroxyl group here. So from here I can count. I say 1, 2. I can say 1, 2, 3, 4, 5. I can say 1, 2, 3, 4, 5, 6. So the longest chain, the longest carbon chain has got 6 carbon atoms. So the prefix of the parent name will have the prefix of the parent name will be X. Now the next step, number 2, you're told number the carbon atom from the end near the hydroxyl group. So if you look at this structure here, the hydroxyl group is more nearer on the left hand side than on the right hand side. So I begin numbering from here. 1, 2, 3, 4, 5, 6. So the parent name for this compound therefore becomes hexan hyphen 2 hyphen ol. Number 3, you are told locate position of the branches. So this one is a methyl branch, this is a bromo branch, and this one is a bromo branch. So this methyl is attached to carbon number 3, so it becomes 3 methyl. This one is 4 bromo, and this one is 5 bromo. So it means you're going to have 3 branches. You're going to have 3 hyphen methyl, 4 hyphen bromo, and 5 hyphen bromo. Now the bromine atoms are 2 of them similar, so they'll be named as 4, 5 hyphen dibromo. So the name of this compound will be, because you're told to now name them alphabetically, so I started bromo. So I say 4, 5 hyphen dibromo, hyphen 3 hyphen methyl hexan hyphen 2 hyphen all. Now next we want to look at is how to draw the structural formula of a branch alkanol. Draw the structural formula of 2, 3 hyphen dichloro 3 hyphen methyl pentan 1 all. So the first thing I'm going to begin there is, first of all, start with the parent name. They're called pend. Pend means 5 carbon atoms. So I draw 5 carbon atoms. 1, 2, 3, 4, 5. Join all of them with single bonds. Then make each carbon to have 4 bonds. Then give them numbers from either side. Let me give number from 1, 2, 3, 4, 5. Then I'm told pentan 1 all. It means the OH is in carbon number 1. So I place here an OH. And I'm told 2, 3 dichloro. So carbon number 2 has a chloro, Cl. Carbon number 3 has a chloro also. Then carbon number 3 has a methyl. So I put here CH3. Then the rest you place hydrogen atoms. Now the next thing we want to look at is isomerism of alkanols. Start by defining isomer, isomerism. Isomerism is existence of 2 or more compounds with the same molecular formula but different structural formula. Isomers are 2 or more compounds with the same molecular formula but different structural formula. Alkanols have got 2 types of isomerism: positional isomerism and branching isomerism. So A, positional isomerism. This one is obtained by changing position of the hydroxyl group. For example, I'm told draw and name any 2 positional isomers of propanol. Propanol, the molecular formula is C3H7OH. So that means to draw the 2 isomers, I draw the 3 carbon atoms. 1, 2, 3. Join with single bonds. Each carbon to have 4 bonds. Then the first isomer, I place hydroxyl group either here or on this end here. So I place it here, OH, and then the rest becomes hydrogen. The rest becomes hydrogen atoms. So that one I call it propan 1 all. To draw the next isomer, I draw the next 3 carbon atoms. Then each carbon to have 4 bonds. Then I change position of the OH here to the second carbon atom. So I place it here, OH. Then the rest becomes hydrogen atoms. So I said that this first one here, because this one is in carbon number 1, the hydroxyl group, it becomes propan 1 all. This one becomes propan 2 all because the OH is in carbon number 2. Now the next isomerism is called branching isomerism. This one is obtained by modifying the structural formula of the preceding isomer. For example, I'm told draw and name any 2 positional isomers. Draw and name any 2 branch isomers of pentanol. Pentanol, the molecular formula is C5H11OH. So the first isomer, I draw the normal chain of 5 carbon atoms. 1, 2, 3, 4, 5. Join with single bonds everywhere. Now place an OH on this end, then the rest becomes hydrogen atoms. The rest becomes hydrogen atoms. Now to draw the next isomer, I remove this carbon atom here, which has got 3 hydrogen atoms, so that I remain with 4 in the chain. So I draw 4 carbon atoms, 1, 2, 3, 4. Make each carbon to have 4 bonds. There was an hydroxyl group here. Now the one which I removed as a CH3 is called a methyl. So it is placed either here or here, not here, not here. So I place it here, CH3. Then the rest becomes hydrogen atoms. The rest becomes hydrogen atoms. Now, this first isomer is called pentan 1-ol. Number from here, 1, 2, 3, 4, 5. That is called pentan 1-ol. This one, I begin numbering from the OH. So I start here 1, 2, 3, 4. So the branch is 3-methyl. So become 3-methyl butan 1-ol.